Okay, to finish up chapter 3, chapter 3, lesson 6, we are going to do example 3. We will skip example 4 for now, the word problems on the next page. In order to do example 3, you have to use the complex conjugate root theorem, which states if a plus bi is a root of the polynomial, then a minus bi is also a root. Okay, if you remember way back when we talked about conjugates, the conjugate, so if you had 2 plus 4i, the conjugate is 2 minus 4i. So this is saying that if you have the 2 plus 4i as a root, then you also have 2 minus 4i as a root. So if you look at example 3, letter A, we have 2 plus I. It looks like we have 3 roots there. Really, we have more than that, because you have to also include the conjugate. And then also with square roots, you've got to remember that a square root is the positive and the negative. So really with A, we have 5 roots, even though it really only shows us 3. Okay? Also, something to remember when we're going through these, because you'll run into this, is that I squared equals negative 1. It's been a while since we dealt with that, but you will have some I squareds in here. Okay, so example 3 is exactly like example 1. So example 1, you were given the roots, you wrote the factors, and then multiplied it out. This is the same idea, except now we have square roots and imaginary numbers to deal with. So let's go ahead and try A together. All right, first let's list all of the roots that we have. So we have 2 plus I, they gave us that, we know that one, 2 plus I. Since we have 2 plus I, we also have 2 minus I. Okay, that's what that theorem we just wrote down tells you. Okay, we have the square root of 3. They showed us that. That's the positive. But then we also have the negative square root of 3. Okay, since when you square root something, you get a positive answer and a negative answer. And then we have 1. Whole numbers are just whatever they say they are. So you don't have to do anything fancy with them. So now these are the roots that we need to deal with. Remember that when you are turning your roots into factors, that you use the opposite. So we have a 2 plus I, so to make this a factor, it's x minus 2 plus I. Then we have x minus 2 minus I. We have x minus the square root of 3. This one will be x plus the square root of 3, since it was a negative up there. And the 1 is positive, so it'll be x minus. Okay, so you always have to remember to use the opposites when you're putting them in. 2 plus I is positive as a whole, so it's a minus 2 plus I, or a minus 2 minus I. Then since the square root of 3 was positive, we did a minus. Since the negative square root of 3 is negative, we do a plus. And the 1 is positive, so we do a minus. Now, we need to do our distributing. So first, let's start with these two. We'll get the harder ones out of the way first. So since this is x minus 2 plus I, right here, we need to distribute this negative to everything inside these parentheses. Same idea over here. That's minus 2 minus I. So we need to distribute that negative. So let's do that first before we start distributing things. So we have x minus 2 minus I. If we distribute the negative The same will happen here. So now we have x minus 2 plus I. Okay, now we can multiply those. So let's distribute this x to everything in the second set. So x times x is x squared. X times negative 2 is negative 2x. X times I is xi. Okay, now do the negative 2. So we have a negative 2 times x, that's negative 2x. Negative 2 times negative 2 is a positive 4. And negative 2 times I is a negative 2i. Then last we need to distribute that I. So negative I times x is a negative xi. Negative I times negative 2 is a positive 2i. And negative I times a positive I is negative I squared. Okay, so that was a whole lot of distributing. Now we need to combine like terms and simplify this. So x squared, that's the only one. So there's only one x squared. So we'll just put that here. Then we have a minus 2x and a minus 2x. So that's minus 4x. We have a positive xi and a negative xi. So those cancel. Those are gone. I'm going to skip the 4 for now. We'll come back to it. We have a negative 2i and a positive 2i. So those cancel. They're gone. Let's go to the I squared at the end. Remember that I squared is just negative 1. So really what we have back here is minus a negative 1. So when we combine the 4 right here and the minus negative 1 here, 4 minus negative 1 is just a plus 5. So all of that whole giant thing, we get down to x squared minus 4x plus 5. Okay, so those two turned into just this. Now we have some more pieces to deal with, so I'm going to bring the rest of it down. X minus the square root of 3, x plus the square root of 3, and x minus 1. Okay, next let's do these two. You want to multiply the ones that look alike with each other because then things will cancel out. As you saw with all those i's up there, all the i's are gone and we have something that we're used to working with. So now we're going to do the square roots together since they look alike. So these ones we don't need to do anything fancy to start, we just need to distribute. So we're going to do x times x, that's x squared. X times the square root of 3 is plus the square root of 3x. Then we have the negative square root of 3 times x, so that's minus the square root of 3x. Then we have the negative square root of 3 times the positive square root of 3. So it's negative, so we have a negative and a positive. And that is the square root of 3 squared. When you're multiplying the same thing by itself, you can square it. So we have this x squared, so we'll just bring it down. Then we have a positive square root of 3x and a negative square root of 3x, so those are gone. They cancel out. Then if we have a square root of 3 and we square it, squaring a square root cancels, so we just have a minus 3. Okay, those are opposite operations, so they cancel each other. So now we have this piece. We still have the x minus 1 from up top. That has to come down. That's coming down here. And we need to bring this piece down. So we have the x squared minus 4x plus 5. So we're not quite finished yet, but we are at least getting rid of the weird looking stuff. Now we're only dealing with x's and numbers. That's fine, we're used to that. Okay, so let's get some more space here. Now we need to continue our distributing. I'm going to, it doesn't really matter, I'll just do these first two because they're both there. We'll leave the x minus 1 for the end since that's the simplest one. Okay, so we're going to take an x squared times x squared, and that'll give us an x to the fourth. X squared times negative 3 is negative 3x squared. Now I need to give the negative 4x to everything. So negative 4x times x squared is negative 4x to the third. And negative 4x times negative 3 is a positive 12x. Then we have a 5 times x squared, so we have 5x squared. And 5 times negative 3, so it's negative 15. Let's see if we can combine anything to make this simpler. Well, x to the fourth is all by itself, so we'll put that there. Then we have a minus 3x squared plus 5x squared. So that's a 2x squared. We have a minus 4x to the third all alone, so minus 4x to the third. Order doesn't really matter yet. When we get to the very end, they should be in order, but they don't need to be right now. We have a 12x right there, so plus 12x, and we have the minus 15. Okay, now we need to bring down the x minus 1 still. We haven't dealt with that yet. So we're going to distribute again. I'm going to start back here and go this way. It's just easier to me since you only have two of them. Okay, so we are going to do x times x to the fourth. So we get x to the fifth. X times 2x squared. That's 2x to the third. X times 4x to the third, so that's minus 4x to the fourth. X times 12x, that's plus 12x squared. And x times negative 15 is negative 15x. Now we need to do the negative 1 to everything over there. So negative 1 times x to the fourth is negative x to the fourth. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 4x to the times negative 4x to the third will give us a positive 4x to the third. I need to get myself some more space here. Okay, so then we have negative 1 times 12x, so that's minus 12x. And negative 1 times negative 15 is a positive 15. So we have this big giant equation here. We need to combine all of the like terms. So x to the fifth is all by itself. There aren't any other to the fifth, so we'll just put x to the fifth. So we use that piece. If we have an x to the fifth, the next piece would need to be an x to the fourth. So as we're combining like terms, we can kind of put it in order to save ourselves some time later. So we have a negative x to the fourth minus an x to the fourth. So that's a negative 5 x to the fourth. Negative 4 minus 1 is negative 5. After x to the fourth is x to the third. So we have a 2x to the third here and a 4x to the third over here. So we have a 6x to the third. Then we have a 12x squared and a minus 2x squared. So we get a 10x squared. And then we have a minus 15x and a minus 12x, so that's minus 27x. And this plus 15 is down here, so we put plus 15. And then this whole giant thing is our answer. Once you have all the terms combined, you know that you needed 5. If you remember from the beginning, we had 5 roots, so we needed an x to the fifth, and we get this whole long problem. Okay, let's try one more together. Let's go ahead and do B.